Recall that we can use the sine, cosine, and tangent functions to solve for a missing side length of a right triangle given an acute angle and the numeric length of at least one side. Remember that these three trigonometric functions can be memorized using the acronym SOHCAHTOA. Suppose we're asked to solve for the value of x in this right triangle diagram. Well, the first thing we have to do is identify which sides we've been given in relation to the acute angle that's provided, which is the 36 degrees. So in relation to the 36 degrees, we've been given the adjacent leg, because remember that the 18 is on the same side as the right angle and the given acute angle, so 18 would be the adjacent leg, so I'm just going to put an A for adjacent. And, of course, the two sides that form the right angle are always the adjacent leg and the opposite leg. So if this is the adjacent leg, that means that this leg has to be the opposite leg. So at this point, we're going to ask ourselves which trigonometric function uses the opposite leg and the adjacent leg. So the tangent of an angle is equal to the opposite leg over the adjacent leg. So we're just going to plug in the information that we've been given into this equation. So for theta, we have 36, since that's the measure of the acute angle. For the opposite leg, we have x. So the x goes on top of the fraction on the right side of the equation. And the adjacent leg is 18. So 18 goes in the denominator of this fraction. So I'm going to leave you guys to solve this equation on your own to see if you can figure out the value of x. But right now, we're going to switch gears. So far you've learned how to solve for a missing side length of a right triangle when given an acute angle and the numeric value of one side. But if we're given at least two side lengths of a right triangle, we could solve for a measure of a missing acute angle using the arcsin, arccosine, and arctangent functions. These functions are also referred to as the inverse trigonometric functions, or the inverse sine, inverse cosine, and inverse tangent functions. Now, suppose I want to figure out the measure of the missing angle where you see the theta symbol. Before I can do that, I have to figure out which side lengths I've been given in relation to the theta. Now, the 4 is the opposite leg in relation to the theta, so I'm just going to label that as O for opposite. And then the 3 is the adjacent leg in relation to the theta because it's on the same side as the angle we're trying to find and the right angle. So I'm going to label that as A. Now, which of the inverse functions we just learned about uses the opposite leg and the adjacent leg? Well, that's the inverse tangent function. So we're going to take the inverse tangent, and then in the parentheses, we're going to do the opposite leg over the adjacent leg. So we're taking the inverse tangent of 4 divided by 3, and then closing the parentheses. So how do we actually calculate what that is? Well, first we want to make sure that our calculator, if we're using a TI-84 Plus, is in degree mode. And then we're going to hit second tan, and in the parentheses, you're going to just put 4 divided by 3, and then close the parentheses, press enter, and you should get back the measure of the angle at theta, and that's going to be 53.1 degrees. If you're doing this on an iPhone calculator, you want to hold your calculator the long way, so horizontally, and what you're going to do is you're going to type in the value inside the parentheses first. So type in 4 divided by 3, then hit the second button followed by the tan button, and you should get back 53.1, assuming your calculator on your iPhone is in degree mode. So if it says rad in the bottom left-hand corner, then you know your iPhone is in degree mode. If it says deg, like DEG, then it's not in degree mode, it's in radian mode instead. So you just want to press that to switch it back into degree mode. Now, suppose we want to solve for the measure of the missing angle, theta, in this right triangle diagram. This time, instead of two sides of the triangle, we've been given three, the 9, the 12, and the 15. This means that we have more than one option as to which trigonometric inverse function we can use in order to solve for the missing angle measure. So as per usual, we're going to start by labeling our diagram according to which side is the opposite leg, adjacent leg, and hypotenuse. So the 9 is opposite the angle we're interested in finding. So the 9 is going to be the opposite leg. So I'm just going to put an O on that side for opposite. And that would make 12 the adjacent leg, since again, the legs are the two sides that form the right angle. And 12 is the adjacent leg because it's on the same side as the right angle and the angle that we're trying to find. And now that we know the opposite leg and adjacent leg, that means that the only remaining side is going to be the hypotenuse. So I'm just going to put an H over the 15 for hypotenuse. Now at this point, we can choose which combination of two sides we want to use in order to solve for the missing angle. So suppose I decide to go with the 12 and 15. I'm going to ask myself which inverse trigonometric function uses the adjacent leg and the hypotenuse. The answer is the inverse cosine function. So if I hit second cosine on my TI-84 graphing calculator, I'll pull up the inverse cosine function, and then in the parentheses, I could just put the adjacent leg, which is 12, divided by the hypotenuse, which is 15. And when I press enter, I get back the measure of the angle at theta, which is 36.9 degrees. However, it's important to note that we're not just limited to using the inverse cosine function to solve for the measure of theta. So if you decide to use the 9 and the 15 instead of the 12 and the 15, then you would be using the opposite leg with respect to theta and the hypotenuse. So then you would use the inverse sine function, since that's the function that contains the opposite leg and the hypotenuse, and you would take the inverse sine of 9 divided by 15. You could also use the inverse tangent function if you were to use the 9 and the 12, since 9 is the opposite leg with respect to theta, and 12 is the adjacent leg. So you could also use the inverse tangent of 9 over 12, and you're going to notice that all three of those inverse trig functions will give you back the same value for theta.